In this lesson, we introduce Metasploit Framework, a powerful tool for developing and executing exploit code against a remote target machine. It is well known for its anti-forensic and evasive tool. Here we show the initial screen of a terminal where the Metasploit framework first gets started. The four icons created using the character are the four steps of the penetration testing process. On the left upper corner, we first perform reconnaissance, maybe using Nexus or other footprint kind of to find out what systems are vulnerable. And we learn second on the upper right, which is like a tank. The step is to launching the exploit. And the third one on the lower left is delivering the payload. And once you deliver a payload, get into the system, the fourth one on the lower right is looting. Basically, try to seek treasure hunt, do treasure hunt and seek valuable information within the victim machine. It first create a database. If you don't have it, for saving all the session data and command for future usage. They make it very convenient. Metasploit was created by H.D. Moore in 2003 as a portable networking tool using Perl language. In 2007, it was completely rewritten in Ruby. 2007, it was acquired by Rapid7, the current company. Metasploit release 3.0 began to include fuzzing tool, which means you are changing the input accordingly and randomly so that you can explore additional software vulnerability. And instead of just exploring the known bug and using the known exploit, it is more powerful. Current release is 4.14. It has come out since February 24, 2017. They update very regularly, including new feature. The basic steps for exploiting a system using the framework include: first, choose and configure an exploit. And there's a whole bunch of lists in the database. Exploit is a code that enters a target system by taking advantage of one of those vulnerabilities or bugs. Second, choose and configure the payload. Payload are codes that will be executed on the target system on successful entry by the exploit. For instance, a remote shell or a VNC server, and they are typically much bigger than the exploit. Encode, third one is encode payload to evade IPS, IDS detections. The fourth one is execute the exploit. Those are the standard steps. As shown here, there are the current release 4.14 has 1,639 exploits, and there are other auxiliary versions for various operating systems and devices. Those devices including Wi-Fi, the Cisco router, and so on. And there are 472 types of payload. It's a crazy number. Those payload, depending on their category, can create admins account, create injected and set up VNC server on the victim machine, create shell, remote shell, and injected a keylogger so that it can keep track of keystroke and send it back to the Kali machines. And there are totally 40 different encoders. Here we show how to penetrate a machine running unpatched Windows XP operating system with Metasploit Framework using the MS0326 DCOM vulnerability. First, we indicate to the MSF, Metasploit Framework, the specific exploit we will be using. From the Nexus vulnerability scanning result on this Windows XP running on 128.198.51.184 IP address, we know the third critical vulnerability is MS0326. The exploit payloads are organized and saved in the Metasploit with the directory structures. For example, the first directory is exploit, the second directory is a window, followed by the name of the services. In this case is the DCE RPC, which stands for Distributed Computing Environment /remote procedure code. RPC is one of the provided Distributed Computing Environment services on the Microsoft Windows. We then tell MSF the IP address of the local Kali system because we need them to victim machine to send back the data, and remote victim machine's IP address, followed by the command exploit. The default payload is an interpreter called Meterpreter. M stands for Metasloit. MSF first set up the reverse TCP process. As you see, once the exploit launching, there's a whole bunch of start entry there indicate the steps. First, it says that a reverse TCP process listening to port 4444. That's a very common port they use on Kali, waiting for the messages to come back. Okay, and it then connect to RPC port 135 of the victim machines and try to bind. Once bind to it, it send a buffer overflow exploit sequence. Once it get the remote shell, it then send a Meterpreter code as a payload over to the victim site. The code will establish connection with port 4444 established earlier. Now a remote shell is established to allow the hacker on Kali Unix to launching any command. We then check if the system is running as a virtual machine. And this kind of information can allow us to exploit the vulnerability of virtual machine monitor underneath, or at least we will recognize that this current virtual machine is share the underneath resources, just CPU, storage, and network with the other machines provided by the same VMM, and allow us to attack in the future. We also list all the applications installed on the victim. Those list of application and their release number allow us to look at potential vulnerability in the database for attacking these applications, and maybe modify those applications so that we can escalate the privilege by substituting the software and planting the malicious code on the documents and data produced by these apps. And in such a way, we extend the reach when these documents are dispersed and carried and sent over to other machines. By typing the shell SHLL, we can, from the Metasploit interpreter, we can then execute any window command on the virtual machine. If it is a window machine, we can navigate up and down the window directory system using the CD, and we can listing them using the dir, and using Notepad or other listing tool, we can look for treasure and valuable information within the system.